I'm really perplexed by how this vintage variable resistor works. It's a speed controller for a sewing machine. You press on it with your toe to change the speed. Inside are stacks of carbon discs that get squeezed. And when they're squeezed, the resistance changes. Can someone help me understand the underlying principle of operation there in terms of physics, chemistry, material science, or something else?
So as we can see here, the range of this variable resistor is somewhere from 3 kilo ohms in gradations down to very close to 0. Of course, this is meant to be used with a foot, not with a hand, and you can get rather fine control over universal motor speed with this device. This one's a little long in the tooth and can use some cleaning. So the thing that has me actually perplexed about this device is how it really accomplishes this change in resistance. I was expecting to open it up and find some resistance wire and a coil and a wiper moving back and forth, but that's not what I found at all, as you'll see momentarily. And by the way, don't try this at home with your own old equipment. I know a lot of people have these devices in their attic or their garage or their basement, and they're, well, this one's probably from the 40s or 50s, and there may be some asbestos in it. And so I'll be taking care of that sort of carefully and adequately, I hope. But I do not recommend that anybody else do this. So when you step on this plunger, it's depressing this lever, which pulls this mechanism back, which is attached to this screw in back. A little more light on there, maybe. I don't know, maybe you can see that screw a little more clearly and see that moving back and forth, and watch this mechanism come back and forth. So, oh, by the way, Singer sewing machine controller, 9545 volts, 0.7 amp. Singer Manufacturing, part number 196131-04, made in Great Britain. I don't know where in Great Britain. Maybe the Old Dart? Who knows? Someone out there knows. So let's see. First thing to take apart here. I'm not remembering clearly. I've taken this apart before, but not in many years. Because it had degraded to the point where it was unreliable and had to be replaced. in order to sew properly. So this is a unit that can be taken apart. And I'm going to bring in some paper toweling to hold any dust and detritus that may fall off of this. And okay, that's supposed to come off of there. Okay. It was just, so I've already replaced, the last time I was in here, I replaced the asbestos pads with rubber pads that were really working quite well. Darn. So let's see, this actually forms part of the adjustment. You can adjust how sensitive it is in various ways. So you end on this screw here, this adjustment screw, and you have to hold this nut from spinning, which I shall do with a pair of pliers here. Let's see if I can get myself a pair of pliers to keep it from spinning. There we go. Am I still in shot here? Oh, yes, I am. What do you know? Okay. Trying to do this with the camera and filming and things getting in the way off camera and all that kind of good stuff. Oh, looks like I might actually have to make some room on my bench. And I just cleared this bench. This is a brand new setup. That's just the way I am. And a really old and chowdered slotted screw head that has seen better days and better fitting screwdrivers than this. So set screw is tightening it up. So it's probably making things a little harder. So we'll keep going here. That's a little easier. Slow but steady. This was the height of technology in 1890, 1920, somewhere around there. Okay, well, I don't have to take that all the way out. Yes, I do. Okay, so that has come off. And now I can just unscrew this little nut by hand. Notice it says Simanco on it. Focus. Go on, focus. Nice computer. So it says Simanco. So it was the Singer Manufacturing Company. So this is the These are two contacts that sit on the top of these little bullet-like thingies here. I don't know if you can see that. And do those just come out at this point? I forget. No, they don't. I'm gonna have to pause here, maybe. Refresh my memory on how this thing works. Yeah, maybe. I just want to clear my way to one of the screws. So this is a recess that's got some putty in it to keep the screw from undoing itself. There we go. So now that it's been released, now what we see is a whole stack of what appear to be carbon discs. So internally, when this is put together, this contact, this contact sits in the end of this little pip, and it applies pressure to the carbon discs, which are connected to these contacts. And so the upshot of it is that the variable resistance is created by varying pressure on this stack of carbon discs. Now what I want to know is, how does that work? From a physics perspective, from a material science perspective, why is the resistance of two carbon discs like that different from when I take the two carbon discs and press down on them? Or the stack of carbon discs and press down on it. And of course I can do that experiment of proving that it is, but the whole mechanism proves that it is. I will do that experiment later. Heck, I'll do the experiment now. So if I take a little piece of wire here, I don't want to crack any of these discs. The thing. A little antsy about that. So here we have auto ranging. It's a mega ohm. And what I can do, I can measure this flat surface rather than. So just two carbon discs is 31 ohms, and if I push them harder, well, now they're down to about 6 ohms. So what the heck happened? Oops, hope I didn't crack that one. What's going on here? Whoa. Is the microcrystalline structure being compressed more tightly together? Am I just pushing atmosphere out of the way? What is going on, guys? That's what I want to know on this piece of 100-year-old technology, or it's over 100 years old. This particular instance isn't. It doesn't have a patent number on it, so I can't trace it that way. It's probably out of patent by this time. There really is no indication that I can see of a manufacturing date, unless Singer sewing machine experts all around the world are screaming at me saying, yes, we know exactly when that was manufactured, just tell us. Here it says V8, and here it says U B522/1. Thank you very much, and if anybody has any ideas, I really appreciate a pointer on this. Thanks.